record.
In this video, we're going to discuss really basic bends and seams that you normally find in HVAC. So in this packet here, basically we're going to have about 6 square inches pieces of metal where we're going to do projects where you're going to be using most of the hand tools and some of the machines to fabricate sheet metal. The very first one we're going to do is taking a 6 by 6 inch square piece of metal, and we're going to cut out a circle, and we're going to look at how to find the dead center of a circle. By the 6 by 6 inch square, we're going to have a circle of 4 inches. To do that, we need to measure the radius of the center, and the way I did it, you probably cannot tell, but from this here, I took diagonal across and found the dead center of that. And since it's 4 inches, I will find a radius of 2 inches. So I would take my dividers, these dividers, and I will measure out exactly 2 inches. And once I get that, then I would find the center of the intersecting of the two diagonals, and I would use my dividers to do it. The way to do this, first you got to have, these have to be sharp, and it cannot be bent. And matter of fact, these were kind of damaged, and I took a file to file the edges back down so it can actually have a very precise bend or scribe on the metal. So once I put it in, I will take it, I will keep this pivot point, put pressure on it while I drag the outside of it, and if it's done correctly, you should be able to do it in just one sweep, as I'm doing now. And once I scribe it, I would have a complete circle. Now, two things you can do. The very first one, I wanted just a circle cut out and have a complete circle. The second one, I want the center of this cut out and have it precisely looking with no burrs or anything. So I'm going to start out with the shears. And when I look at this, I would determine which one to use. If you notice, I'm using the green hand, the left-handed instead of the right, and if you follow, it's going to be very difficult to turn this way. This one's designed to cut clockwise, while the reds are designed counterclockwise. So I'm right-handed, so I'm going to try to cut counterclockwise. And here's the secret of having very good cuts. You turn when it's not a straight cut, cut anything curved. You cut and turn exactly at the same time. If you do not, it will leave fishtails or little sharp edges on it, which will look ugly, plus it can end up cutting yourself. So I'm turning and cutting at exactly the same time. Another thing, I do not close the shears completely. I'm turning it. Right now I'm cutting it pretty quick, and to do it correctly, you keep your cut edge of the shear on the line, exactly on the line. And if you do that, you will have really clean cut. I'm going to go back and clean up some of the things where I was talking and wasn't paying attention, but I'm going to clean this up. And what's nice about aviation shears is that you can really cut a sliver out. I mean, a very thin piece by cutting it. If you notice, there's no burrs on it. Now, to show you the difference, by using the right-hand shears, this came out all ragged, while the centerpiece came out undamaged. Difference between the two. Now, I'm going to show you another piece. I already scribed this already, found the diagonal, took my 2-inch dividers, and then was able to scribe around it. Now, the thing is how do we protect the outside while we don't care about the inside damaging it? So what we have to do is start out, we're going to have to punch a hole in this piece of sheet metal to do it. You could take your scratch awl, and I'm going to get a hammer real quick, and I'm going to walk over to the vise and just grab a, thank you, just going to grab a hammer, and I'm going to just punch a hole, and I'm going to go back to the table. the way to do this is that just punch a hole, and once you get the hole, then I would bend it upward. I'll be able to slide it out really easy. I bend it upward for a reason. I'm going to go back to the table where you'll be able to see how I use my aviation shears. I'm going to take the greens now, and because the aviations, the edges are always very pointed. The offsets are a little bit different. The ones offset, they have a bigger angle for the handle, and usually the jaws are built out. The straight ones works out better. So what I would do, I would put in the edge, and I would just start cutting out, making the hole bigger. And once I could get inside of it, then I could start cutting. Now, it doesn't matter if I use the rights or the reds, as long as I go to the edge. It's one of the neat things about aviation shears. I put tension on it, I would turn it. While I got tension on it, I could make a 90-degree turn without damaging anything. And now I could start cutting. Now, the reason I'm using the green shears, if you can see this clearly, maybe you can zoom in so you can see it at the jaws. This is the top blade. However, the bottom blade comes up as really high. And as I turn, you're going to take that metal down here and kick it up also. I do not want to damage this outside of it, so I don't care about the inside. So as I cut, this top portion of the bottom jaw will kick up the metal and kind of damaging it while it doesn't affect the outside. I'm going to show you the difference. If I show you the reds, the red is just the opposite. It's on this part of it. The bottom jaw is actually have this portion of it high. If I try to use the reds, which is the right hand, and cut that direction, it's going to end up damaging the part I want to save. So that's the reason why I decided to use the greens. You could physically look at it. So as I turn, again, I turn and cut at the same time. I do not close it all the way. I will keep my blade cutting edge on the line, directly on the line, not off the line, not inside the line, but on the line, because that's what cuts. And because I'm turning and cutting at the same time, I should not have any burrs as I cut. Cut and turn, cut and turn. Now, if you need to come back to clean up anything, aviations, if the shears are in good condition, if it's oiled, if it's adjusted correctly, it should not have any problems of cutting very small portions out of it, little slivers if you really need to. And here again, I'm just going around and cutting that small portion right on the line. And if I need to, I could come back around and okay. Now, I could go back, clean it up if I need to, if anything. So right now I have a circle cut out. It should be 4 inches. If it works out correctly, this 4 inches should drop right into that piece, and it should fit without any gaps. So again, using the right shears to cut the piece. Now, the next piece is going to show you how to use a pick spurt machine. A pick spurt is a seam used to lock ductwork together. The purpose of it to make it very strong so it doesn't fall apart, to lock two pieces of duct together. To do that, you need to have two pieces. And one would be one side of the duct, which you have a flange on it, a fold. A fold, anything that's bent. So the term fold is any metal that's been bent over. And usually we have a fold of 90 degrees, and it would be folded over a 1/4 inch. So if you look at a pick spurt seam, one side of it will be a 1/4 inch folded over 90 degrees, and the pick spurt machine will have another amount of take-up on it that need to be added to the duct. Most of the time, most pick spurts are going to be around 1 inch. Matter of fact, if someone have a scribe that we'll call the Christmas tree, I'll talk about that real quick. There's many different types of scribes. This is one here, which is used to scribe multiple different sizes. And this one is designed to, I got it set right now for 1 inch. I'm using a 1 inch for my Pittsburgh machine. And then have a different type, which is, I call it the Christmas tree because it looks like the side of a Christmas tree. And this one have multiple different preset scribes on it. We're going to use a 1/4 inch for the other side of the flange for the Pittsburgh. So to use that, you see the 1/4 inch on this level here, you flip it on the back side and you'll be able to scribe it. I'm going to try to do it backwards. I'm right-handed, so using my left hand. There we go. It's a 1/4 inch. I don't know if you can see it on here. If you can zoom in and show you that it did a precise 1/4 inch without measuring it. That's the nice thing about these type of scribes. It saves you time when you're fabricating. When you got a shop and you're trying to produce a lot of different pieces of duck and measure it, it certainly takes time. I'm going to show you the 1 inch again. I just showed you 2 ways to do it. And if you notice, it's right on top of that 1 inch. So I'm going to run this through a Pittsburgh machine, then I'm going to go to a brake to measure and to bend out the 90-degree 1/4 inch flange. Okay, let's go to the Pittsburgh machine first.